Hey everyone and welcome to the Retro channel, and today we are looking at a brand new way to get HDMI digital video from the NES. It has been a few years since we had a HDMI solution for this machine. The last one was the High Def NES project, which has been out of stock for some time, and I don't think it's going to be coming back. So there is now a new way that doesn't involve any case modifications and only basic soldering skills, and that is the PPUdigitizer from Copper Dragon. If you've been following the channel for a little while, you may have seen the LumaCode videos that I put out last year, and they were basically a similar idea, but for the Commodore 64, 128, and I also did one on the Atari 8-bit computers. These all use a format known as LumaCode, which was also developed by Copper Dragon, and it's a way of encoding digital information into an analog video signal that is then sent out over a single wire to something like the RGBtoHDMI or potentially other upscalers, which then decodes that information and gives us a pixel-perfect digital video output. What these digitizers basically do is monitor the data going into the video display chip, so in this case the PPU in the NES, and use that to create a LumaCode signal, which is then normally fed out using an RF output. So basically you disable the RF output and use that jack to carry the LumaCode signal instead. So far I believe there's digitizers available for the Commodore 64 and the Commodore 128 and also the Commodore VIC-20, the Atari 2600 and the Atari 8-bit line of computers have one, and also the ZX Spectrum and the TMS 9918 based systems also have one. And these are at the moment all available through Copper Dragon's Tindy store. What isn't available at the time of filming is this PPUdigitizer, and that's because this is very much in an alpha state, and Copper Dragon sent this over to me to do some tests with. The NES we're going to be installing this into is a PAL model. I believe at the time of filming there's no support for NTSC systems, but again, that could all change, so be sure to check the pinned comments on this video. Disassembling the NES is very straightforward. There are 6 Phillips head screws around the bottom that need to come out. And with those screws removed, the top cover should just lift off. Next we need to take off this RF shield, so we've got another 7 Phillips head screws around the edges here that need to come out. With those out of the way, this RF shield should just lift off. You just have to get it around this heatsink here. And then we've got another 6 screws to remove. So these 2 at the front of the cartridge port, these 2 at the mid-rear of the cartridge port, and these 2 around this RF modulator / power supply. You don't have to worry about mixing up the screws as they're all the same size except for the 2 that sit at the rear of the cartridge port. There's no need to remove these 2 screws. With all those screws removed, you should be able to lift this whole assembly out. Now, one thing you might want to do is just hit the power button. That just makes sure that this big capacitor here is discharged. With that all done, the easiest way to disassemble the rest of this is just to flip the board to the side, and that'll give you access to unplug these connections over here. Let's get that out of the way, and we should now be able to lift off this bottom RF shield. Now you'll probably notice that there is a little modification over here already, and that is from a composite video output upgrade that I did a few months ago. So I'll link that video up there. It's basically just cleaning up the composite video signal, but if we can get HDMI from this thing, then who cares about composite? So the PPUdigitizer is designed to fit on the bottom of the PPU, so the other side of this board, which is something I didn't think of. So we do actually need to remove these 2 screws from the cartridge port because we need to take this whole thing off. And with those 2 screws removed, this part can just slide forward, and that gives us access to the underside of the PPU chip, which is just around here. One of the benefits of the PPUdigitizer is it doesn't require removal of the PPU, which can be quite tough, especially if you're new to soldering. So to install our PPUdigitizer, all we need to do is check the orientation, which is signified by this little notch on the silk screen here, and make sure that matches the orientation of the PPU itself. So both notches should face in the same direction. So before we go soldering anything, it is recommended just to stick some tape over this side of the board because the digitizer itself actually sits up this way. I'm going to use a bit of electrical tape to do this, but you can also use Kapton tape if you prefer. Now of course we want to cover up the bottom of the board without covering up those pinholes, so we'll need to cut this down just a little bit. All right, that should be our tape trimmed to size or close enough. I'd say that's close enough. And of course that's covered up where that notch was, but as long as you have it this way, so you've got these ground and Luma pads closer to the RF modulator, you should be good to go. So I'd give it around 2 or 3 seconds with the soldering iron just to make sure that solder flows through to the actual pin itself. And I might do the opposite corner now just to sort of secure this all in place. Just like that. Now you'll notice some of these pins have a white square around them. That just means that they don't actually need to be soldered, but I'd recommend just soldering all of them anyway. Alright, that should be everything soldered into place. It does look a little bit messy because there's some spent flux on there, so I'll just give that a quick clean with some IPA. Of course, this part is totally optional and it's not really going to make any real difference apart from just looking a little bit nicer. Alright, that part's done. The only thing left to do is run a couple of wires from here to the RF output. So we're going to repurpose this thing, and that means we just need to pop this cover off the bottom here. Now you can see I've already made some modifications in here, so you can pretty much ignore most of this. In fact, I'm just going to remove this wire. Basically what I've already done is disconnected this RF output, and I just ran the audio signal from this port over here to this one here. So let me just get that back out of the way. We're still going to have audio over here, so no issues there. And what you want to do here is make sure that all the existing connections going to this RF output jack are disconnected. All you want to have is the single connection in the middle, which actually goes to the center signal pin, I guess you'd call it. Of course, because I already had audio running to that, you can see that I've removed whatever was sticking through these two holes here, which obviously go to this center pin. So you could either just cut these traces around this center pin, or do what I did in the past, which was just to heat these up and then push the actual component legs back through the board. Either way, you just want to make sure that everything has been disconnected from this RF output jack. Now the PPUdigitizer did come with a small length of wire, so all we need to do is hook that up to ground and Luma on the PPUdigitizer board and run those signals over to the RF output jack. So I'm just going to strip a little bit off one end of these wires, flow a little bit of solder onto them just so they're tinned and ready to go. Put a tiny bit of solder on these two pads as well. And I might even just trim those down just a tiny bit, just so the actual wire that's exposed here is around the same size as the actual pads that we're going to be soldering to. So we're just going to quickly heat and done. And then for the other one, heat and done. If you've done it properly, you should now have a nice solid connection. Now, although we've got quite a bit of wire here, we do want to try and keep this as short as possible so it doesn't pick up any interference. So I think our best bet, I'm just going to put my finger firmly over that and route the wire this way so we get a nice bend in that cable, just like that. Then we can just bring it up from this side and solder it over here. And that way it shouldn't interfere with this bottom RF shield, unlike my other mod, which kind of does. Yeah, that should be fine. So we can route it up and into here. So I'll leave a little bit of extra length, just cut it there. So same deal as before, we'll just strip these and tin them up. And because it's not obvious which one is ground and which one is the Luma signal, I'm just going to do a quick continuity test. So one of these should just go to ground, so pretty much anywhere. That's 182 ohms, so it is not that one, it's got to be this one. Yep. So we want to connect this wire to ground and this wire to the center pin of the RF output jack. Just add a little bit of fresh solder to that output jack. This is where tweezers are a good idea. Make sure I've still got that correct. Yep. So our ground wire just needs to go somewhere around this area. Looks like that point right there is probably ground. Yes, it is. That'll do. Right, and that should be it for the installation. So yeah, pretty straightforward. Just take that back off for a second so I can reinstall this lid, which I think only goes one way. Probably that way. Maybe that way. Cool, that's it. And there's a little gap in the lid itself here, so those wires just go straight through there, no problem. So I won't go throwing all the screws back in just yet. We'll just throw the cartridge port back on just so we can give this a quick test. When you're doing this, just make sure that this little bit of plastic goes underneath the board. You don't want to have it sitting on top like that. So we'll just throw back in the 2 screws at the rear. And then we just need to reconnect the power and reset switch. So that goes in the blue connector, just like so. And then our 2 controller ports. If you get these the wrong way around, then obviously port 1 is going to become port 2, and you'll have to just swap these 2 connections. But I think that's the right way. I guess we'll find out. So I won't worry about putting on the RF shields for now. Let's just test this thing out first. All right, cartridge. Give this thing some power, and I might just test the composite video output, make sure the NES is still working correctly before we go messing with the HDMI stuff. All right, let's make sure we didn't break something. It's looking good. Oh yeah, we're good here. Too bad I'm not. Right, the NES is still working, and as you can see, it doesn't affect the original video output, so you can still use the composite output, but let's get set up for HDMI. So as I mentioned, the RGBtoHDMI does support LumaCode, and potentially other upscalers will also support LumaCode in the near future. But for now, we're going to go through how to use the RGBtoHDMI version. So this one already has LumaCode support, so it's got this little extra wire here that will plug directly into the old RF output. And for the RGBtoHDMI, we just need a Raspberry Pi. In this case, I've got a Raspberry Pi Zero. So we'll plug that little hat on top, and this particular one, like I mentioned, is just designed for LumaCode. So this add-on board with the RGBtoHDMI is also available through Copper Dragon's Tindy store. You can also use the RGBtoHDMI plus the analog board and do it that way, but this just offers a more neat and tidy solution. All we need to do now is stick the RGBtoHDMI software on a micro SD card and stick that in the Raspberry Pi. Now, as I said, this PPUdigitizer is still in the alpha phase, so it's not officially supported by the RGBtoHDMI, but I imagine it will be in the future. So we just want to make sure our SD card is formatted as FAT32. Possibly exFAT might also work, I don't know, to be honest. Then we just want to head to the RGBtoHDMI GitHub repo and go to the latest releases over on the side here. And if we just scroll down a little bit, we should find the latest release right here. Once you've downloaded that zip file, you just need to extract all the contents to your micro SD card. Cool, and with that done, you can now take the micro SD card and stick it in the Raspberry Pi. Then we just need to give the Raspberry Pi some power and of course plug in HDMI and plug this cable into our RF output jack. We should see a screen like this, and then when we power the NES on, it might look something like this. We just need to press this button to go into the menu on the RGBtoHDMI and change the profile to NES LumaCode, which at the moment, because this is all in alpha state, it is currently under test, but that may change once this is actually, up for sale. And there it is, looking pixel perfect. Now, of course, we don't have sound at the moment, and that is because the current version of the RGBtoHDMI does not support audio, although I believe there is work going on to make that a possibility. Hopefully that's something that will come in the near future, but as for now, we need to run audio separately. So some computer monitors might have a separate jack for audio, so you can just plug it straight in, but a lot of consumer TVs will expect the audio to be included on that HDMI cable. So if you don't have a separate audio jack, you could either use some powered speakers or an amplifier, or potentially even get a HDMI audio embedder, which takes a HDMI input and also allows for separate audio, and then puts all that out over a single HDMI cable. One more potential option is this thing over here, the OSSC. There is some work going on to add LumaCode support to this, and the good thing with this is it has a separate audio input, so you can run a video signal and audio signal and have that all come out over a single HDMI cable. So that would remove the need for something like this. Of course, if LumaCode support does become official with the OSSC, I will definitely do a follow-up video on that. For now, we're just going to use the HDMI audio embedder, so let's get all this hooked up. So we'll plug our LumaCode back in, and then we'll plug audio into the side here. I'm just going to use a 1 to 2 RCA adapter, just so we can have dual mono output, and then just a regular RCA cable to 3.5mm jack. That can plug straight into the audio embedder. Give the Pi some power and the audio embedder some power. And then we have HDMI out of the Raspberry Pi going into the audio embedder. And because we've got audio hooked up there, we just connect another HDMI output cable to our display. Power on. And it sounds like we now have audio. And even my gameplay has gotten better. Maybe not speedrun level quality, but you know, not too bad. So let me get this thing reassembled and we'll do some final tests. Right, and with the console back together, you wouldn't even know it's been modified at all. In fact, I might just put a little label here so I know that this one has the LumaCode installed. There we go, that'll do. Now, of course, I have spent a number of hours testing this thing out with a little bit of Zelda, and I can't fault it. The image looks absolutely perfect. I couldn't ask for more from the good old NES. Copper Dragon did mention there is an issue with the RGBtoHDMI not currently supporting the color emphasis bits from the NES, but I'm sure that will be fixed with future updates to the RGBtoHDMI software. So I don't really consider that a big deal. There's a small list of games that actually use those bits, and it's usually just to like dim a pause screen or something like that. So not a big deal and likely to be fixed by the time this probably goes on sale. So yeah, I can't really fault this thing. The only niggly part is the audio issue, but again, we may get support either from the OSSC, which already handles audio, or audio support for the RGBtoHDMI sometime in the near future, fingers crossed. I think that's kind of all I have to say about this thing. Yeah, it looks perfect. It's really easy to install compared to other options, and I can't really fault it. So a huge thanks to Copper Dragon for sending this over for testing. And yeah, I think this is the way to go if you want pixel perfect output from your NES. Like I said, it is currently only working with PAL consoles, but hopefully Copper Dragon will be able to support NTSC consoles once he gets his hand on an NTSC NES. Of course, I'll put any important updates in a pinned comment on this video, and if there's something major that changes, I'll probably do another video on this thing just to update everyone with that. But for now, that is it. I'm going to get back to playing Zelda, and thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down in the video description. And yeah, that's it from me, so I will catch you next time. Bye.